In this video, I'd like to look at two ways that we can find or describe inverse function. One method uses algebra and the other method relies on the graph of a function. So say that we're given a specific example and we're asked to find the inverse function. Here we have f of x equals 3x minus 2. We can find this using algebra using a series of steps. First, I can write this in terms of x and y. So the original function is y equals 3x minus 2. Then I can switch the x and y values. That's what the inverse function does. If the original function maps an x value to a specific y value, the inverse function is supposed to perform the opposite action. So let's reverse or flip the x and y values here. X equals 3y minus 2. We've just created a new function. This is not the same as the original function. This is the inverse. But we now need to solve this function and express it in terms of y, the output value. So let's take this equation, x equals 3y minus 2, and let's rearrange it to solve for y. So I'll add 2 to both sides. I get x plus 2 equals 3y. And I divide by 3. We have y equals x plus 2 over 3. This is the inverse function of f of x. So I'm just going to describe it using function notation, and specifically this notation for the inverse function. F inverse of x equals x plus 2 over 3. Let's perform the same operations with a new example. I want to find the inverse function for f of x equals 3x over x minus 2. This is a rational function. So I'm going to write the function in terms of its x and y values. I'm going to switch the x and y values. I'll write x equals 3y over y minus 2, and I'm going to solve this for the output value y. This takes a little bit of creativity. The first thing I'd like to do is multiply both sides by y minus 2, and we end up with this equation. X times y minus 2 equals 3y. Now I'm trying to solve for y here. It might be good for me to distribute the x value on the left side and to move the terms with y to one side of the equation. So I'm going to subtract 3y from both sides. I'm also going to add 2x to the other side. So what I'm doing here is writing any term with y in it on the left side and any term that doesn't have y in it on the right side. Then I can use a trick of factoring to help me isolate y. So on the left side, both of these terms have a common factor of y, and I can factor it out. Y times x minus 3 equals 2x, and we'll finish by dividing by x minus 3. So y equals 2x over x minus 3. This is the inverse function, and we'll write it using our formal notation. F inverse of x equals 2x over x minus 3. So there's a way of finding an inverse function algebraically. We can also roughly describe inverse functions graphically if we have a picture or a graph that we are looking at. We can find the inverse function for a given graph by reflecting that graph diagonally across the line y equals x. This is the same thing as switching the x and y values for specific points of that line. So if I have the function shown below representing f of x, let's imagine sketching f inverse of x on the same graph. And I can do this by putting in the line y equals x. That's a diagonal line with slope 1 that goes right through the origin. This is roughly the line y equals x. And I'm reflecting each point across this line. So there should be a mirror image somewhere over here for every point that is currently on this side of the line. Let's see if we can make that reflection. It looks like we should have a point right here. It looks like we should have a point right here. It looks like maybe we should have a point right here, and so on. So it's looking like our picture for f inverse of x is going to look something like this. I'm going to label this as f inverse of x. There's a rough sketch of the graph. We obtained it by reflecting the graph across this diagonal line. We could also confirm it by making sure that the x and y coordinates are switched for the new points that we just graphed. For example, the point 0, -2 was on the original function, so that means the point -2, 0 should be on the inverse function. The point 2, 0 was on the original function, so the point 0, 2 should be on the new function. So here is one graphical way to think about what an inverse function actually does. It's a reflection across a diagonal line.